In order to measure sediment quality, we need to collect samples from the environment and bring them back to the laboratory for testing. So we collect these samples on board ship using a grab sampler. And we take that sediment sample and we partition the samples into containers for chemical and toxicity analysis. Or we'll take the sediment and pass it through a screen that separates the sediment particles from the animals, then preserve the animals and identify and count them back in the laboratory. When we measure sediment chemistry, we're looking at three main types of constituents. Things like grain size and organic carbon, or trace metal concentrations, or the concentrations of trace organics. The toxicity analyses usually use more than one species. We look at endpoints such as survival, growth, or reproduction following an exposure of 2 to 28 days in the laboratory. So these measurements are pretty easy to make. There are routine methods available. The hard part is figuring out what they mean. So we're also developing thresholds of response for each of those three lines of evidence to help us interpret the data, and also developing guidance for how you combine or integrate the three lines of evidence to make an overall assessment of sediment quality in the environment. Now, these measurements of sediment quality are really useful, but it's not all the information that we need to make good management decisions. We also need to figure out what's the cause of sediment quality impairment, something we call stressor identification. So one of the best methods to do that is what's known as a toxicity identification evaluation, or TIE. So here at SCCWRP, we're also developing improved methods for doing TIEs in the environment so that we can figure out which chemicals of the complex mixture in the environment are most important in terms of affecting sediment quality.